So I think we can start. Hi again to our new Lieber webinar. This is Konrad speaking. Today you will see the latest trends and updates on code generation. Code generation has a long tradition within our company at Lieber. I think it was one of our first plug-and-play products. And the feedback of the last years from our customers has been incorporated into the new version 3 of our product. We have taken this as an opportunity to hold a webinar on this subject. And before introducing today's speakers, I want to make 2 announcements. If you have any questions during this webinar, please use the Q&A dialog of Zoom. You can see this button at the bottom of this application. We want to answer them at the end of the webinar, and we will also send out the questions together with the answers, and of course also the slides and the recording within the next days. Second announcement, on June 17th, we kindly invite you to the next webinar on configuration management in model-based systems engineering. And for this, please check our news entries on our website. And you, of course, you will be invited to this webinar via email. Our today's speakers are Daniel Siegel and Richard Deininger. Daniel is a well-known expert in MBSE and is heavily involved in standardization organizations like the OMG or in COSI. Richard is enterprise architect, expert, trainer, and consultant. And I would say that our code generator called Embedded Engineer is actually their baby. So that's it from my side. Daniel, Richard, it's your turn.
Thank you, Konrad, for the introduction. So this is Daniel.
Yep, this is Richard. Hi.
And today we're going to show you some of the stuff around our latest version, Embedded Engineers 3.0, that was just released 2 weeks ago. And we will talk about generating MISRA compliant C or C++ code from models to enhance your traceability. And yes, you can do it from UML or SysML models. And I think we move on to the next slide already. So this slide is our logo, and it's interesting because we have the links on the bottom where you can get the software, and also a link to the help page where you can read the content and all of the stuff around embedded engineering.
This will come up at the end again for you to write down.
So the main questions and doubts we always hear when it comes to code generation from UML or SysML is always questions. You know, people don't know where to start, how to introduce it. So we wrote down some of them, and we will try to answer them in this webinar today. The first thing is we want to show you the most simplistic way of generating code that also already provides a big value. It's just to generate H files from interfaces from your model mixed up with traceability information to requirements. What are some of the advantages of code generation on a more wider scope is one of the topics we're going to cover. Do I always have to model everything is also a very good question, because in some tools you really have to bring your full solution into the model. In our case, we have more flexible approaches to do that. How can I trace the requirements down? This is also one of the key questions around all this topic, how to span your traceability from the ALM tools to your source code. How can you do little customizations and adaptations? If we have enough time, we'll show something. If we don't have, we will point you to the documentation in our proceedings. And the truth about round-trip engineering is one of the questions I'm always happy to answer. So how to ensure consistency? In the old days, I don't know if you can remember, I certainly can. We did traceability with these Excel tables, and it was always a real pain in the back. and it was outdated the minute we were done, or maybe while doing it even. So today what we try to do is we have our requirements in most companies, or most of our customers have the requirements in a requirements management system. Some do the requirements directly in Enterprise Architect, and you have a connector or some input mechanism to get your requirements into the model. This is this eco-friendliness box I have here. And at the end of the day, you need a pointer to the requirement in your source code, like this add covers requirement 1. Also a job I had to do by hand in my past quite often, and it's again one of these jobs that tends to be never finished. So how we handle this today with a modeling tool in between, we bring the architecture, or in this case maybe even the implementation model, and set traceability links between, for example, a state machine or a class and the requirements. Once we generate the code, we will have pointers to the requirements also in the code and not just in the model. This is one of there is onboard features for code generation in Enterprise Architect. And this is one of the big differences to ours, that we can bring in pointers to other model elements in the generated code. So enough talking, let's show embedded engineer, Richard.
Okay. So first we show the requirements engineering and how to get your requirements inside the code. And for this we have here a small interface called motor controller. And we have a package with our requirements, just some simple requirements on what to do with the motor controller. In this case, I just simply drag drop the requirements onto the new diagram and check them one by one. So motor controller, every motor should implement the motor controller interface. Okay, that's okay. We don't need this for here. We want to have an initialization method where everything is checked. We want to have a testing method for some testing purposes. We want to stop the motor, in this case, in case of emergency, for example. And we want to simply run the motor with two values of direction and the speed in RPMs. So let's just model the whole stuff. I just open the features browser here and say, okay, we want to have a initialize method. Let's call it init. We want to have a run method. Let's give it the 2 parameters like direction. Let's keep it simple, just an integer, and speed in RPM. Then we add the stop function and we add the test function. Maybe even with a, because we have multiple testings in here, maybe even with a test number, we can give it so we can test. How it's implemented, it's up to the developer. In this case now we want to link our functions with our requirements to show what we have done. So we just drag and drop a connector, a trace connector to our requirement. And since we are especially want to trace it to this operation, we simply click on the left-hand side of the connector, link to element feature, select the operations, and say, okay, this is the initialization feature. And we do the same for testing and for stopping and running. So run, I think, is the next one. Let's simply link all together. Trace, again, just use the pointer up here, drag it down, and use trace.
And as we often have questions, how you can bring the code generation into the game between MBSE, systems engineering, and software engineering. Even if your software engineering department is on another tool, you could use SysML interfaces for this exercise that Richard is now doing and deliver H files to your software engineering as the files they have, as the interfaces they have to take into account to build a proper system.
So, and And then the last one, testing. And now we have all our requirements traced to our operations. And let's generate code from it. So you see what will happen. So you have at least the interface for your developers. To generate code, you simply select the package where the interface or the class is generated. You give it the embedded engineer stereotype by clicking on the stereotype tag, selecting the appropriate profile, liber embedded engineer, and give it the LL embedded stereotype. In this case, you will get new tagged values in the property window. First, the language, you can select between C and C++. Then the generation directory, you can input here a direct directory picked by hand. You can even use relative paths, in this case relative to the AP file and so on, and also the paths variables from the enterprise architect as you already know them. As soon as these steps are done, you simply right-click on Specialize, Embedded Engineer, and Generate Code. This will open the generation progress window, and it will show you what will be generated, what kind of language will be generated, what files will be generated, and if there are any errors. In this case, everything was fine. I can right-click now on it again and go to Open Generation folder. So it popped up on my side, of course. I'll just drag it over here. So we have it here. We have a UDI file that's for UML debugger, but that's another topic. And we have the H file here we just generated. And when we open it, we see generated just this instance. And we have our init, our run, our stop, and our test function. And we have the implementation for our requirement for initialization, for run motor, for stop motor, and for testing, with the name in it, and with a unique ID referencing back to the element inside the model itself. So if we want to fulfill all our requirements, we simply go back here and generate a class to also realize our last requirement. The class then is our motor class. Motor class, and we realize the interface. We simply select all the functions, of course. Now we have the function in here, and we also realize, in this case, this requirement. So this class will realize our requirement here. Simply done. We even can input some code if we want to. We simply double-click one of the functions, go into our code tab of Enterprise Architect, and say, okay, init shall be done here. Save it, and again, simply generate the code. Now we have 3 files generated, of course, our interfaces and our class with the H file. And when we go back to our generation folder, it's popping up here, we see our class, our interface and our class file. And when we open this in with our editor, we see the H file, of course, includes our other H file, our interface. And we have our implement, our requirement number 1, that we always should use the motor controller interface for it. We have the C file in here with all the functions, even with our code, or in this case, in our comment in here, with all the other functions already defined by our interface, and our interface unchanged as before.
Thank you, Richard.
You're welcome. And we go back to our slide.
So the next topic we want to discuss is how you can generate code from behaviors. What we showed today, up to now, was kind of level 1 of code generation. It was the stubs or static code generation inside operations. And now we will look into a more dynamic way of code generation that gives you extra functionality. Basically, we will gonna show you how to generate code from activities and state machines. Why do you want to do this?
Sorry.
Basically, the reasoning is most of the time that you have complex functionality that you need to discuss with other people. Drivers can be functional safety, driver can be UI complexity, or documentation requirements. And of course, again, traceability, because I can then link a state to a requirement if I have a state machine. Obviously, there is algorithms where it doesn't make sense to detail them with a behavioral code, maybe because they come from a different tool, and we have capabilities to integrate old algorithms that are very well proven in use, or algorithms or classes or C files that have been generated by other tools. So in the next slot, which is our biggest demo slot today, I guess, Richard will show you how to develop C with activity diagrams and state machines.
Okay. We again switch to Enterprise Architect. In this case, into our abstraction package. Let's close this one here. And at first, I'll show you how to use external libraries or external classes already present from your legacy code, for example. This is simply done with Enterprise Architect by using the development ribbon button, and in this case, C code. And I've simply linked two H files, in this case, the Arduino H file and the standard IO H file. Of course, not all of them, just a small sample of it. We simply import it. It's popped up on the other side, of course. So we imported these new classes in here, and we have the Arduino, and we have the standard IO file as classes imported. In this case, these are classes, but we only have the H file, and we don't use them as class, but like interfaces. In this case, we need to do some change in here. We simply go in here and say, okay, these are interfaces. Because Enterprise Architect will always use its naming convention by prefixing every function with the class name. In this case, we don't want this to happen, so we need to define these two as interfaces, which we have done now. And in this case, we have two classes set up here already. In our code part, we have a logging and we have our button. Forgot it to put it over here. We will start with logging and simple activity diagrams and how to use them. So in this case, we want to have a simple logging mechanism where we want to show you simply log something by using printf out of it and printing it out into the console. We add a behavior, in this case an activity, with a diagram, and we call it info because we just simply want to log information. We want to, of course, log text, some text in here, or a message, text. In this case, this is no specific type, but a general platform-independent type. So a string would be a character array, of course, in C, but we use it as string. Save it, and then we have then a activity and a parameter with it. To use this, we usually, with lieber, drag drop the activity on here, and then also drag drop the parameter on here. So we have the parameter linked to the activity, and we see the information from this comes from as a parameter from the activity. And now we want to use external libraries called standard IO with our printf function in here, and want to log something out. For this to do, we would need to call this function. And to do this, we usually create a new action, and we would give it a call operation action. But with Enterprise Architect, I think since 14, it's pretty easy. You simply drag drop the function onto the diagram. And on release, Enterprise Architect knows that you want to have a call behavior action and generates it for you. So we have our call behavior action. The next thing we want to do we want to check the behavior and synchronize our parameters. So we have all the action pins in here to also give them the object values we need. So synchronize parameters, and then we get, yes, of course, save it. And then we get our 2 parameters. So now we can call this printf function in here. The next thing we want to do, we want to log, of course, that we want to log information. In this case, we want to have, for example, info in front of the string. And we do this in Enterprise Architect and with Embedded Engineer by simply using a simple action and control-click on the diagram. In this case, we open control-click, we open the context menu, and we use a value specification action. In this case, we specify a value. We can use the name or the effect as we like, and Embedded Engineer allows to use both. In this case, we use the name just to see already what we will define, and we call it info, %s, of course, lower s, sorry. And then we say, okay, we start initially here. We have a control flow to the value specification action, and then we flow along to call this function. And then we want to have these 2 parameters filled with the information. For this, we use the return pin of our value specification and an object flow to our first parameter. Simply done. And the second parameter is, of course, the text. We inputted it as parameter from the activity diagram, and simply also just drag drop a object flow connector over there. And this way, we simply call a printf with info %s and the second parameter with the text. This is a pretty complex way and a pretty UML specific way of doing it. We also provide you, as Daniel already told you, with a more flexible way, because every customer always asks me, do I need to use write variable action, value specification actions, call behavior, call function actions, and so on? And the clear answer is no, you don't have to, but you may as you like. And the level on the complexity you put into your diagrams is always up to you, always up to the customer. You can model it as complex as you like, but you can keep it as simple as you like. And for this, I have already 2 examples. In this case, our warning. And when we open it, you see the same thing in here. I'll just make it a little bit bigger here. We have our activity. We have our activity with our parameter. The parameter will also be generated, so we need it. And then we simply have an activity diagram and an opaque action. An opaque action is simply a normal action, drag drop down here, with no further specification of what this action will do. Enterprise Architect calls this atomic or opaque action in UML. And then you simply go into the action field, into the effect, and type in the code you want to have inside this action. In this case, we have the same thing. We want to have a printf with a warning, %s, and the text, which is, again, the parameter we put down in here. The same thing can be done, again, easier. In this case, we go back to our code view and open the debug. And when I double click on debug, I can go into the static code, as you've seen previously. And again, you can input the code right in here. You have some sort of syntax highlighting in here as well. That's Enterprise Architect and Enterprise Architect specific dialog. Of course, you can have the best of both worlds, or even more complex if you want to. In this case, we have an error operation and we have an error behavior. And when I open the error operation down here, you see we don't have any code inside the error operation, but we have a behavior specified simply by selecting an element down here. And you see we have already selected an element. It's called Embedded Engineer 3.0, abstract code logging error behavior. So our error behavior up here. Meaning that when this function is called, it internally will call this function or this behavior. And when we take a look at this, it's basically the same implementation as we already saw in info. The only thing different here is that we have the value specification down below, and first we'll call the operation and then we'll specify the value. In this case, a value specification will be resolved by the code generator itself when it's needed to be used. The only thing you need to do is have a control flow to it whenever inside your activity. So these are the 4 ways now how to generate code or how to generate behavior from it. And again, you need the Lieber embedded engineer stereotype. We need to have a generation language set. We set the generation directory. As soon as we have done this, we just need to click on generate code, and it will output our behavior into our files. So in this case, we have 5 classes generated because of the button and the signal, but this will come up later. Let's go to the code. Let's look at the button. Logging. Let's look at the logging files. Open these. And we have here our H file. In this case, our definition, we have always standard in there for embedded engineer. And then we have our error behavior. That's the activity we called from the error function. Then we have another activity, the info, which we modeled, was one of the first activity we modeled. We have the warning, this is the simple action, the opaque action. And we have the debug, which is simply an operation as it states here. And we have the error operation, which calls again the behavior. And if we take a look at the C file, we have the same thing down here. We have our error behavior, which hasn't got any code in it, so I don't know why. Funny. We have our info. This worked fine. So you see we have the value specification and our parameter object action. We have the simple warning with our syncable user case, with our opaque action in here, with the code simply put in it. We have our operation, and we have the call to our error behavior down here. So this was a simple and easy way of how to get behavior into your model, simply using activity diagrams. And the next step would be to use state machines. In this case, we also have something already ready for you. This is a state machine. In this case, we want to show how to read a button. We simply want to implement a state machine which knows if a button was pressed and or if it was pressed for a long time, so long press or press. And to use this, we show our newest feature in here, the code editor, which we implemented in Embedded Engineer 3.0.
And I think people that are with us for a longer time will especially appreciate this feature, because finally you don't need the code dialogues of Enterprise Architect anymore. They are replaced by add-in dialogues that are context sensitive and model aware.
Exactly. And they also provide you with a syntax highlighting and auto-completion feature, which I will show you shortly. So to use this, you simply, on startup or whenever you like, go to your, either in the main menu, Lieber code editor, or in the context menu, wherever you like, simply code editor, you start it. And then you get the add-in windows, which I currently docked on the right-hand side down here. And it will automatically show you the code for the current element. As you see, we have selected a package. Of course, a package does not contain any code. Therefore, we see a not supported element down here. To use it, you simply select any element, in this case, the read button state. So I show you again, we have the button. Then we want to have a button state, which we constantly will read from the, let's say we use the Arduino.h. Let's do this in here. Let's drag drop the Arduino.h over here. And simply say we want to use this, a usage link. And this usage link will automatically generate and include in our C file. Now that we can use the Arduino code, we can click on the do action, which I previously generated. By clicking on it, we already have something in here. I have got to delete it, sorry. So again, we go in here and we enter our code, simply using the me or this parameter, whatever you set up inside the code generation template. And we say me dot, and you see the auto-completion automatically auto-completes to button state because we have only one attribute in here. So auto-completion already done. And we say me dot button state equals, and then we use any other function we want to use. Let's call it digital read and D1. So we use the digital read from Arduino and read the digital input 1 pin. Now we click on save, and then we go along. And when we come back, we see it was saved. When I change something in here without saving, it will get lost. You can specify the behavior of this save button by using the model settings. And we allowed you a code editor save strategy. The default will be discard changes, so you need actively to click on save to do anything. We allow you a auto save changes, which will automatically, as soon as you leave the element, will automatically save all the changes. So it's up to you to have your code ready and running and syntax ready and everything checked. Or we have prompt user, where you can where you will get prompted by the dialog that you have unsaved changes and you shall save them before pursuing. We will leave this as it is, as this was the default state before. Okay, now we start with our read data. So every time we enter this state, or every time we are in state, we read the data, our button state data, and then we usually are in release state because nobody pressed the button on start. And then we have our pressed state and our long pressed state. To get from A to B, we simply use the icon, the arrow again. And in this case, we use a transition. Drag it over here. And you see on the right-hand side, we get two elements for code. In this case, it's our guard and our effect. Because a transition can have a guard and an effect, we have both in here. And you can change both or one if you want to. In this case, we again want to check what's the button state is, the current button state. So me.button state, again, auto-completion in here. And we say, okay, if it's high, then it's pressed, of course. And if it's low, we transition over here. And again, me.button state equals low. Then it's released again. So that would be our first step. And then, of course, we want to have long press. We need to acknowledge this somehow. In this case, we use the transition over here. And since this is not code, but UML-specific elements, we go to our constraints up here and don't enter a guard, but we enter a trigger. In this case, we wait for a second. Let's call it wait 1 second or whatever we like. We say, okay, we want to have a time trigger, and we want to have it 1s. When you go to our help site, you will see we have time units called seconds, milliseconds, and so on. And these are provided by our finite state machine structure, which you can implement yourself and influence yourself. So it's up to you what kind of timing you want to have in here. So in this case, we want to have 1 second, and we save it. So we have it pressed. When it's pressed for 1 second, it's go over to long pressed. And on this side again, when it's released, we want to go to release. So we do the same in here. We transition over and say again, me.button state equals low. Save it, and we have our state set. Of course, now we have a simple state machine where we can say, okay, we have a button and we want to have press and long press in here. To use this, of course, we need some kind of signaling. And for this, we can signal other state machines. We can send signals to other state machines if we want to. And we use signals. On the left-hand side here, you see we have already a long pressed and a pressed signal, and we have a signals enumeration class in here where we store all the information for these. To use this, we simply have an activity diagram with a send signal action. Inside the condition, we use the long pressed element. So if I open this, you see this is the long pressed signal in here. And the same goes for the normal pressed signal. Oh, sorry, it's this one here. So we have the pressed. Embedded Engineer has a feature called the send signal action, where we assume that you have some sort of send signal action in there, and we assume it's called send signal, and its parameters is the signal itself, where you then can store your signals and queue them and use them however you like inside other state machines. So the implementation of this side on how to use the state machine and how to send it signals is usually up to the user, because we don't know what your implementation target is. We can say, okay, you can use threads, you can use interrupts, you can use queues, we don't know it. So it's up to you. You can implement it yourself, and it will work predefined. So we'll do it simply by, again, clicking on the transition. We use an effect as behavior as effect, and we use the long press in here. So it will send the signal, save it, do the same in here. So as soon as we run this transition, we will send the signal out, or we will show the need to save the signal somehow. And that's pretty much it, which we need to do.
Richard, when you generate code, we have one question that we can look into right now because it fits our agenda. We have a question: can we add our source code file template to be used for generation? I think this goes along the lines of modifying the header of the source code files.
If it's regarding header, usually templates we have for code generation, we only have for documentation parts, because the code generation itself is usually done by embedded engineer and is hard-coded to have the best speed and the best performance for the customers.
But we have customers that have customized code generators in operation.
Of course.
And it's very simple with a C-lang style formatting to format the header part of the source code files, right?
Yeah, if we use Clang, C-lang, whatever you call it, in here. So by simply going to the model settings, you have a C-lang style option in here, where you can set all the C-lang or Clang or whatever it's called properties. We have some prefixes in here which we provide, but as soon as you use them, you can go to the C-lang options and edit them in here. So that's the way to modify your code.
And we have one last question that also fits this topic area. You now have two places to enter the code into the model.
Yeah.
Which one wins if you use both? I would assume the last one that hits save, right?
Exactly. The difference in here is, so if I go up here and say 2, as soon as I leave this element and click on another one, it wants to save the changes. So you get a question if you want to save your constraints up here. If you click on yes, it will save it. But if you update it down here, again, whatever you entered inside your settings, it either gets discarded or it gets auto-saved. But the last one to save will win. But we urge you to use the R code editor, because we have inputted here, of course, syntax highlighting, auto-completion, and all the other good stuff you get with a normal editor. For example, you see where each bracket is started and stopped, it auto indents it, and so on. So you get a lot of functionality out of our implementation. Okay, let's just generate code to show you what we will get from this, and take a look at it. And here we are in the button.a, button.h, button.c. Let's reload it. We have our state machine types, we have our long press, short press, and so on. And we have our state machine initialization and running. And then, of course, we have our big state machine here with our state low, state high, and so on. With the button press, this long press, this short press.
Richard, how about this syncable user code comments I've seen in your code?
The syncable user code comments, sorry, let's go back here. We have with our log warning, the function we've previously generated, we have a syncable user codes tag in here, which will be generated for all opaque code inside of Enterprise Architect, meaning our opaque action, our decision and stuff like that. Everything that's modeled, so for example, our call behavior action does not get such a thing, such a syncable user code, because this is behavior model, and we don't want the developer to allow to sync the code or to change the code in here. So if you want to have some backwards, want to have to sync your code, to reverse engineer your code inside of Enterprise Architect, you can simply enter your changes in here. For example, in this case, we want to have warning written big, so everybody sees it. So we just changed the warnings file in here. And anything, the only thing you need to do is simply go in here, and the next time you generate code, so let's open the warning. You see it's written small in here. And the next time we generate code, the code generator automatically checks your code files and the syncable user code tags and sees that something has changed. And as soon as it changes, it will update this, and this, I think, is a refresh error from Enterprise Architect. I hope so. Okay, let's just reload the package. Reload. Yes, of course, save it. Info. Now it was warnings, sorry. Logging, warning. I'm going to go in here. It's still written. Okay. Okay, that's the demo gods. They are not with us today. There might be some issue. We've tested it already, but you can use this on any kind of function. And we also implemented a conflict checking. So if, for example, I have...
The last time this happened to me in a demo, I forgot to hit save in one of the two tools.
That might be an issue. Okay, I simply close everything so everything is saved, just to be sure. So with our new demo, I'll show you, we change both sides here. Let's change debug in here, save it. So now it's changed. And let's save debug on this side, and let's give it debug underline to make it really ugly. I saved it. Yes, it should be saved. Just close it just to be sure. Just to make everything safe. Okay. And then, so we have changed both sides, the code and the model itself. And now we generate the code. And we see we have conflict in here, code generation conflict. You also get warned here. There was a warning while generation. You can scroll up here, code sync conflict. You can open the change report. You see in here. Oh, now it has it. Okay, it was a simple save error, obviously. So we have
been there, done that.
So we have our change conflict in here, which shows us we have warning and we have debug changed on both sides. So this was deleted, this was added. So we have the one in the model and the one inside the code. And this will also get updated inside the model. So if I right click on show relevant element model, it will automatically open the model and also select the operation. And when we now open the operation, oh, it was open already, we see on the right-hand side in our code editor that we have both sides in here, what was inside the model and what was inside the code changed. It is, of course, up to the developer or up to the architect to resolve this conflict simply by updating the code and say, okay, the one written in uppercase is right, of course. We can do the same, of course, with our warning. Save it again, and when we generate the code out,
it should be fixed again.
It should be fixed again, of course.
Richard, we are running a bit short on time. Maybe we go back to slides to sum it up to have some time left for questions.
Have our changes here. Of course. Sorry, I was...
No, it's good. Perfect.
Okay. Here you go.
So this was our second demo slot. So round trip is always a big topic when it comes to code generation. Full round trip, as you imagine it, is a muse. I can show it on a stage. I can create the illusion of it working. In the real world, we have not seen it working. And reverse engineering is a solved discipline for stubs, but there is no proper reverse engineering that we are aware of for behavioral models.
Sorry.
You would need a very precise modeling pattern to do it, and for a custom solution it can be done according to our knowledge. For a general product, we don't see it at the moment. CodeSync for operation for this, I think, was demoed by Richard, and you could see that this is really handy because you can edit your bodies in your favorite IDE. And full round trip is not usable in the real world. Is also interesting because this methodology to change stuff that comes from the model only in the model is something that we learned from medical device customers that are using model code generation for a very, very long time. And this is one of the #1 business rules. If you define an operation in a model, only change the operation name and parameters in the model, never in the source code. And this is know-how from 20 years of UML to a model to code generation that we learn from customers from the medical industry. This we already covered. Yeah, to generate code from UML SysML, what we can support at the moment is we can generate code from interfaces, UML or SysML. We can generate code from classes or blocks. We can generate code from activity diagrams. An activity diagram typically is on the level of an operation in our context. And we can generate code from state machines on the class level. Full behavior can be modeled with most of the things that the UML and FUML standards propose. And our cool new feature for Embedded Engineers 3.0, despite a lot of small changes where the feedback of our customers was taken into account, is obviously the new code editor. We also have a version available for Magic Draw or Cameo, but sadly, so far, the only thing it's missing is the new code editor. Key takeaways. I think my favorite one is this, you can already start just by generating interfaces. You don't have to do all of the model from, all of the code from the model day one. You work to expand your traceability in a steady process. You can integrate legacy code and libraries. I think we've shown this very well. You can link requirements with code in the model. In most cases, requirements might be imported from ALM systems. In other cases, they might be edited in Enterprise Architect directly. We didn't have a lot of time to show this easy to modify the layout of the code. If you have questions, feel free to reach out to us and we will schedule something, especially on this topic. And I hope I told you the truth on round-trip engineering. There is one question. Is there some example model and code available for download? I think this is a perfect start here. If you go to getting started and click on the help.libaliber.com, you have the getting started example that is step by step. And you have also a download. The download section, you have various enterprise architect models.
Yep.
And very interestingly, there is our unit test model as well. And there you can see all the capabilities of embedded engineer. All modeling constructs it supports are laid out in our unit test model. So it's like a reference book. And we try to improve our documentation every day. If you have hints or remarks where we could especially improve, we are happy to improve it further. And if you want a personal web meeting on more advanced topics or give us feedback on our product if you're already a customer, we are very happy to take it. We have one more questions. The presentation slides will be sent to the attendees, and we will even share the recording. So that's it from us. Do you have more questions? Any more questions? If you don't have more questions, feel free to reach out to us, give us feedback on the talk, tell us what we should cover in the next talk, and we will be happy to schedule either a private session, or if you have a topic that seems to be interesting for most people, we can even do a public session again. To reach us, the most structured way is to write to welcome@libaliber.com, and the email will get forwarded. We have one additional question. What version of AA can I use this with? I think there is two answers to this. There is a version and an edition. Yeah. I think the minimum edition that makes sense is corporate. Professional. But it doesn't make sense, but you don't have the SysML.
Yep.
You just can use it for UML. And I would recommend any enterprise architect higher than 13.5, most probably.
Yep.
If you choose a new one, I would go with 14.1 or something like that.
I think that the lowest we could go would be EA version 12, but it's not tested properly.
It's unofficially supported.
Yeah.
Okay, perfect. I think we come to an end here. Thank you, Dan and Richard, for the good presentation. And again, on June 17th, we have our next webinar on configuration management. So thank you also from my side, and goodbye.